Okay, Wildcats. Today we're looking at Wednesday, September 19th, solving absolute value equations on page 13. If you would, update your table of contents. All right, now your table of contents are updated. Let's take a look at the notes. All right, as you're looking at notes, you may or may not hear, but I've asked the Temple Wildcat drumline to give us a beat, some background music for the video. So enjoy the Wildcat drumline. All right, solving absolute value functions on page 13. Definition: absolute value of x is when you have x, that's x is greater than or equal to 0, and negative x, x is less than or equal to 0. Solving steps. Step 1, isolate the absolute value. Step 2, graph the left side. Step 3, graph the right side. Step 4, find the x values of the intersection, and then graph. All right, find the x values of the intersection of the graph. All right, types of absolute value function solutions. When you have no solution, the absolute value equals a negative number. The graphs will not intersect. When the absolute value of x equals 0, you'll have one solution that intersect at 1. And then when the absolute value of x equals a positive number, that intersect twice. So you would finish up your notes. All right, now your notes are updated. Let's look at the examples. Example 1. Step 1, isolate the absolute value. It's isolated. Step 2, graph the left side. Now that's just the parent function, so we know the parent function points are x and y. Now, they're points when you write x and y, if you write direction using them as direction. In case these are the points of -2, -2, -1. Whoa, not -2, +2. +2, +1, 0, 0, 1, 1, 2, 2. All right, so we go left 2. Oh, I'm not left 2. The point is -2, 2. -1, 1, 0, 0, 1, 1, 2, 2. And I would actually go 3, 3. I would graph them all, because if you could put the points, it's going to be easier to find the intersection. All right, now the next step is graph the right side, which is a horizontal line at 8. So 1, 2, 3, 4, 5, 6, 7, 8. So you see here they intersect here and here. So we find the x values when they intersect. So the solutions are x equals 1, 2, 3, 4, 5, 6, 7, 8, -8, and x equals 1, 2, 3, 4, 5, 6, 7, 8. All right, let's take a look at example 2. All right, so step 1 is isolate the absolute value. It's isolated. Step 2, graph the left side. So here we're going to graph by direction. So first things first, we're going to move the vertex. So the vertex in the parent function is 0, 0. That +1 moves, we move left 1, so there's your new vertex. And then we graph by direction. So -2, 2, -1, 1, HK, 1, 1, 2, 2. All right, so we go left 2 up 2, left 1 up 1, right 1 up 1, right 2 up 2, and we can continue that. And you want to, because if you have all the points, it's easier to find the intersection. All right, so now we graph the right side, which is 3. So 1, 2, 3. Intersects twice, and we find the x values at intersection. So x equals -4, and x equals 2. All right, let's take a look at example 3. All right, first thing is isolate the absolute value. So we add 1 to both sides, we get the absolute value of x equals 4. We know the points are the same as example 1, so -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, so on. now we graph the right side, which is 4. So we go up 1, 2, 3, 4. Here's our intersections. So x equals -4 and x equals 4. All right, example 4. So we isolate the absolute value. So we subtract 3 from both sides. We get the absolute value of x equals 0. Now we know from our notes that when absolute value of x equals 0, it's going to be one solution. So we know the graph is the same from example 3, example 4. So we know it's 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 1, 1, 2, 2, 3, 3. And it should be, I was saying, but I think positive, but it should be -1, 1, -2, 2, negative so on. But no, the same graph. You have a horizontal line at 0. There's your intersection point. The x value at that intersection is 0. So your solution is x equals 0. All right, so let's take a look at example 5. All right, so the first step is we're going to isolate the absolute value. So we need to multiply both sides by 2/3. So 2/3 times 3 is 6. 3 divided by 2 is 6. So 6 divided by 6 is 1. So you get the absolute value of x minus 1. 2 times 3 is 6. 6 divided by 3 is 2. Now we're going to graph by direction. So the -1 tells us we move to the right one. So there's a new vertex. And we know our direction are -2, 2, -1, 1, HK, 1, 2, 2. So we go left 2, up 2, left 1, up 1, 1, and so on. All right, and then now we graph the right side, which is a horizontal line at 2. So here's our intersections here and here. So x equals -1 and x equals 2, 3. All right, last example. All right, example 6. So first step is to isolate the absolute value. So here we multiply both sides by negative. Negative sum of negatives is positive, so you get the absolute value of x plus 1 equals a -3. Now we know from our notes, if the absolute value is equal to a negative, then it's going to be no solution. Okay, but let's graph and see what that looks like. So we're going to graph by direction. All right. So then we know our vertex, the +1 means we go left 1. And then we graph by direction -2, 2, -1, 1, HK, 1, 1, 2, 2. So left 2 up 2, left 1 up 1, so on. Now we graph a horizontal line at -3, -1, 2, 3. We can see here that they do not intersect, so no solution. All right. So at this point, if you understood the example, start working the assignment. If you had questions, remember you could work in the teacher-led station or in a small group session to get help as needed. All right. So with that, have a wonderful Wildcat day.